Okay, in this video, I'm going to be telling you about the law of cosines. And this one's really good. This is a good trick to solve out some triangles, especially in certain situations. Unlike the law of sines, where we could have kind of like gotten away with doing other things, oftentimes law of cosines is the only way to go with these types of problems. Okay, so what I'm going to tell you is look at these two things, kind of starting out with the intuition behind law of cosines. If we know that this third side comes down at a right angle, which it sure is appearing to do, we would know that this side length was 3 because of the 3, 4, 5 thing with a right triangle. Okay, but if we don't know that, or if we can see that it's not going to be a right triangle, then what's going to happen there? Okay, maybe there was, we switched them and they opened up a little farther. So that's still looking a little bit right to me, but it's okay. We could pull out a ruler or something. Like if we know the two sides and there's a third implied side and we know like kind of the shape of the triangle, we have to be able to find this third side length. And that's what I'm going to be able to show you how to do in this video. Now, much like with the law of sines, I'm going to just tell you the law of cosines and show you how it works in the video. But if you're interested in the proof, which is really not too difficult, it's very algebraic, you could click right up here and, I'm sure I could put in a card that would take you on to that video of me proving the law of cosines. But the way this works is that, if we've got triangle ABC, we've got c squared equals a squared plus b squared, which that looks familiar. This is true. This is not like contradicting the Pythagorean theorem or anything. It's just that c squared is a squared plus b squared minus 2 times a times b times cosine of c. And the way this fits in is that, if this is a right triangle, in this case, angle C would be a right angle, and like side C would be the hypotenuse. And the cosine of 90 is 0 for reasons that we'll see maybe a couple of times from now. Okay, but let's get on. Let's do some examples. All right, so the first situation we're going to look at is when you're given side angle side. And in geometry class, I hope they told you that, if you have an angle and the two sides that are right next to it, you've uniquely defined the triangle, right? If this amount of angle is set and, we have A and B, then kind of like I was drawing in earlier, this implies, another side and, we could potentially measure it or something. But for us, we're just going to use the law of cosines. So we're going to, actually, I probably should have left that. Let triangle ABC be an oblique triangle. That means not a right triangle. So, something like that. We can let A, B, and C be whichever ones we want. I'm just going to label it like that. Measure of angle A is 60. Side length B is 3, and side length C is 5. There we have side angle side, right? 5, 60, and 3. Find the value of A. So what we're going to do is we're going to use the law of cosines. Now, there wasn't anything special about the first row of the law of cosines that I read off to you, where c squared was a squared plus b squared minus some other stuff. There's nothing special about the way we drew the triangle, right? This was true for any of the side lengths in terms of the others and the corresponding angle measure. So what I'm going to do is copy in the version that says that a squared equals b squared plus c squared minus 2bc cosine of a. And then I'll just kind of solve this out. Okay, I'm just going to plug in all the stuff and then eventually take the square root. So I'm going to say a squared is equal to b squared, which is 9, plus c squared, 25, minus 2 times b times c, that would be 30, times the cosine of a, which would be cosine of 60 degrees. And let me think about cosine of 60 degrees. Okay. Actually, let's do this by hand. Anything we can do by hand, we probably should. So with a 30, 60, 90 triangle, okay, we know, this is the first thing we learned about trigonometry, the sides sat in a ratio of 1 to 2 to the square root of 3. Okay, where 2 is the hypotenuse, 1 was the short leg, and root 3 was the long leg. Okay, so cosine of 60 is the adjacent leg divided by the hypotenuse. That's 1 divided by 2. Okay, so if I added 9 plus 25 and then I subtracted 15, that would be like adding 9 plus 10. So I've got a squared equals 19. And as a result, I'm going to say a is the positive square root of 19, because it's going to be a positive side length. We're not really interested right here in triangles with negative side lengths. Okay, so we got a is the square root of 19. Now maybe you can try this on your own. This one will require a calculator though, right, because of the 39 degrees. So let ABC be an oblique triangle with the measure of angle B. Maybe I can even draw this for you. Okay, measure of angle B is 39 degrees. Side length A is 5, and side length C is 7. Once again, we've got side angle side. Find the measure, or the length of side B. Okay, so you go on that, try it on your own, check your work against mine. I'm going to just work it. You should have the video paused, and I'll bring up the answers in a couple of seconds. All right, there you go. These worked pretty much the exact same way. I just found, this time I used b squared equals a squared plus c squared minus 2ac cosine of b. Okay, but it's really all the same. It's that the side length squared that we're looking for equals the sum of the squares of the other two side lengths minus their product times 2 times the cosine of the angle we're talking about. And then we just took the square root of both sides, got b equals 4.427. We're ready to move on. The reverse of that problem would be when we're finding the measure of the other angles. So what I'm going to do, kind of just draw x, y, and z, however I feel like it. Okay, x is 25 degrees, side y is 9, and side z is 12. Okay, so we'll find the measures of angles y and z. Okay, this is going to be a little bit more involved. I think what I'm going to do is I'm going to use the law of cosines to find this side length x there. And then I'll use the law of sines after that. I mean, you could use law of cosines if you wanted. But I'm going to use the law of sines to figure out the other two angles. All right, so this x squared is going to equal 9 squared plus 12 squared minus 2 times 9 times 12. Okay, I know what that is, and I guess if I write it like that, I know that's going to be 216 times the cosine of 25 degrees. I'm going to just consult with a calculator. I found that x squared was going to equal 29.238, which meant that x was going to be 5.407. Okay, so now that I've got side length x, I'm going to use the law of sines. I feel like I'm going to need a little more room here. Not much on the paper. So I'm going to say, all right, for, say, the measure of angle y, I can say sine of y divided by 9 is going to equal sine of 25 divided by 5.407. I can solve this out the usual way. Say sine of y is equal to 9 times the sine of 25 divided by 5.407. Hopefully you got plenty of practice on this last time. And say, all right, well, y is going to be inverse sine of that. And, we can use a calculator for that. I'll actually show you my steps there. So I'm going to compute 9 sine of 25 divided by 5.407. And I guess you could have just put that on the inside of inverse sine. But I'm going to take inverse sine of the answer, which I get from down there, and press enter and say, all right, 44.705. So y is equal to 44.705 degrees. I guess I need to zoom out here. All right, so if I've got x and I've got y, I could add that. Okay, so I could add x is 25 degrees to get the total of x and y. And then I'm going to subtract 180 minus the answer. I'll get 110.295. Okay, and get that out of the way, 110.295. Degrees. Okay, and I don't think you need to practice that one on your own. That's more than enough of that practice. That took a while. All right, the other thing that law of cosines is really good for is working side-side-side problems. Yeah, I think they also told you that side-side-side uniquely defines a triangle in geometry. But what I'm saying here is that if we've got, 3 sticks, I'm not going to be able to do this, with this drawing software, but maybe this one's kind of in between them. Okay, if we've got 3 sticks, there's only going to be one way that we can put these together into a triangle. Just envision picking up one of them and setting it, point to point with another one, and then trying to fit the third one in to make a triangle. There's only going to be one way it works, provided that it works at all. Actually, that's not entirely true. Sometimes there's 2 ways, but we're not going to get into that in this class. We'll do that in pre-cal. If you have side-side-side and it's known, that's going to be good enough for us to compute the measure of the missing angles. So I'm going to show you how to work that. So if you've got 8 and 14 and 19, you can draw that. Okay, maybe that's short. 8, 14, Okay, maybe this one's the 14, and this one's 19, and that's 8, and this is just horribly out of proportion. But maybe I'll call this angle A, that angle B, and this angle C. Okay, what I'm going to do is I'm going to use the law of cosines. So I'm just going to, I don't know, maybe on A. Okay, so 14 squared, side A squared equals side B squared. I think that was backwards, but whatever. 14 squared, or 8 squared plus 19 squared minus 2 times 8 times 19. Oh, whoops. 2 times 8 times 19 times the cosine of A. And I can just kind of compute all of this stuff. Alright, so I've got 64 plus 19 squared, that's 425. And 14 squared is 196. So I'm going to need 196 equals 425 minus, okay, need 2 times 8 times 19. Looks like that's 304. So minus 304 cosine of A. Okay, so now I'm going to subtract 425 from both sides, so I need 196 minus 425. I get negative 229. So negative 229 equals negative 304 cosine of A. So I'll say, all right, divide both sides by negative 304 and say cosine of A equals 229 over 304. So I can do inverse cosine to find the value of A. I'll just come here and do that real quick. Inverse cosine of 229 divided by 304. And I've got 41.124. Okay, then from there, I don't think I'm going to be finding all three of these angle measures. Maybe I should. Yeah, I guess I will. Okay, to find the next one, I'll probably use law of sines, right? Because that's a little faster. So I'm going to say sine of B over 19 is going to equal sine of A, sine of 41.124 divided by side A, which is 14. And then I'll solve this one out the usual way, you know, sine of B equals 19/14 of the sine of 41.124. Actually get myself a number. And then I'll run inverse sine of 0.893. And I guess really I took inverse sine of the answer. I'm not sure if rounding off there is going to impact the third decimal of my degree measure. I somehow doubt it's going to, but I'm going to get 63.199. 63.199 degrees. And then I can find the measure of angle C by saying, all right, well, A plus B plus C equals 180. I'm going to add 63.199 to 41.124. I'm going to get 104.323. I'm going to subtract 180 minus that. I don't think you need to see me doing this on the calculator. This is just arithmetic. And I'm going to get C equals 75.677. Okay. And that's us solving out missing angle measures when we're given side, side, side. Right, I do kind of like the next one below it. 1, 2, and square root of 3. This was when I taught pre-cal, and maybe it'd been a while since they'd talked about special right triangles, so maybe they'd forgotten, and I tricked some of them into using law of cosines. Some of them maybe remembered. Okay, so we know that the measures of the interior angles of the triangle with side lengths 1, 2, and square root of 3, that's going to be 30 and 60 and 90. Okay, but let me see if there's any other problem types that we're looking at with law of cosines. Oh yes, the parallelogram problems. Now this is probably not something we're going to be doing in Algebra 2, but it's something I'll just show you. Okay, so I need you to recall from geometry that diagonals of a parallelogram bisect each other. So we've got a parallelogram that has diagonals with length 10 and 20 that are intersecting at a 40-degree angle. Okay, so I just had better draw myself a parallelogram. The safest way would probably be to just have two of the sides be horizontal. Okay, that's a decent parallelogram. Gonna be good enough. Okay, diagonals with length 10 and 20. Okay, if one of the diagonals is gonna be twice as long as the other one, it's gonna have to be way more laid out than that. I'm gonna draw an actual parallelogram. Alright, even still, that's probably not gonna work. Probably wanted to draw that thing like more like a diamond or laid out some other way, but I'm going to say the red diagonal is going to be the 20. And then the blue diagonal, that's going to be the one with length 10, and you're just going to have to forgive me that. Okay, so all right, we've got ourselves a couple of diagonals, and they're bisecting each other. You can even see. Okay, so find the side lengths of the parallelogram that has diagonals with length 10 and 20 that intersect at a 40-degree angle. Okay, so that means that this thing's going to be 40, and these are going to be 140. Okay, and all right, so really what we're going to do is use the law of cosines. How am I going to do that? Okay, obviously by using the information that was given to me in the statement of the problem. Okay, so they give me that the lengths of the diagonals were 10 and 20, so when they get cut in half, they're going to be 5 and 10, and I'll be looking for this, which is x, and I'll use the law of cosines to find that. So I'm going to say x squared equals 5 squared plus 10 squared minus 2 times 5 times 10, that would be 100, times the cosine of 140. Okay, so that means that x squared is going to equal, x squared is going to be 201.604, and I can take the square root of the answer. The faster way is just taking the answer to the 0.5 power and seeing that x is going to be 14.199. Okay, and then we're going to do the exact same thing on the other type of triangle to find, what I might call y. So maybe I'll get rid of the calculator for a second and say y squared. Well, if that red 10 was there, this red 10 will also be a 10. So I could say y squared equals, same thing, 10 squared plus 5 squared minus 2 times 5 times 10 times the cosine of 40 degrees. Yeah, I could have the calculator do my work for me. So we see that y squared is 48.396. We're going to take the square root of that, get y, and we'll say y is equal to 6.957. Okay, and the calculator, we found the side lengths of the parallelogram. Okay, so you could do, if you were interested, try to work that. It's the exact same kind of law of cosine situation. Draw a diagram, work on a triangle, solve for that angle. Okay, but that wouldn't be all that different from the ones that we've already done in this video. Okay, so I'm going to call it here. That's going to be all for this one. Thanks for watching.